Okay, now I want to give a demonstration about how to play with MusicBox Interactive. So I will start with the installation of Docker. So I will just search Docker, and then you can see there are a few links. And then you can go to this Docker desktop option. So here, this will lead you to this web page. And for my Mac, it has an Intel chip. So I will definitely go with this option. So once you make the selection, and then you can just move forward from there, where everything is pretty straightforward. So you may have to restart your laptop to make it work. So once it's successfully installed, you can see here there's a symbol. So that meaning that your Docker is running. So once your Docker is running, you can start with MusicBox. So if you don't have any links handy, I will also do some search. So you search like NCAR, MusicBox, and then normally I just get this first one. This is a GitHub repository, and then you can just click open. And here is all the code and also these MusicBox instructions about how to install and how to run. So what I would do is pretty simple. I just copy this command line and then into a terminal. And then I click enter, so you see it's actually running, getting prepared. So now it's ready. And then you can go back and I'll just click open, and then you can see here we go. We have MusicBox Interactive open. So we can just get started, and you can see there are a few options. We can select from a few examples. We can also start from scratch, and also we can load configuration files. So for the example side, currently we have 3 examples built in MusicBox Interactive. One is the Chapman cycle, which is chemistry of the ozone layer. We also have the flow tube wall loss example. And also we have the full gas phase chemistry. This is based on the carbon bond 5 chemical mechanism. So we're gonna play with stratosphere chemistry and also the troposphere chemistry, one example for each layer. So let's start with the Chapman example. So here, if you click open, you can see for this Chapman, like the simple Chapman, it has a few species there already. And yeah, you can feel free to click open each different species. And then when you click one species that are involved actually in these reactions, you can see there's a very interesting this diagram that you can see like the reactions between different species. And here you can also add properties for different species. You can add description, you can add molecular weight. And here by default, it has the absolute convergence tolerance that's related to how you use a chemical solver. Okay, now let's also take a look at the reaction tab. So here you can see there are a few reactions already built in, and then you can feel free to click each reactions. And then you can see here for each reactions, and then you can see here you can specify different reaction type. And also you can specify reactants and quantity and also products and yield. So when you try to build your own reaction, you can add reactants and also add products, like something like this. And you can also add a scaling factor, and also you can give it a musical name. And for this musical name is because music are going to use this to kind of identify the specific reaction in the music box. So do not choose like similar name for like means the same name for 2 different reactions. Everything needs to be identical. Okay, so after these chemical species and reactions, we can also see a condition section. So here we have general conditions, initial conditions, and involving conditions. So for general conditions, currently MusicBox is built based on the box grid, and we can definitely change the chemistry time step and also the output time step, and also the simulation time. So you can feel free to change the unit and yeah, and also change the number here. And for the initial tab, so here is the place you can define all these initial values, initial concentrations for different species. Like for example, here we have a few species and we give them like initial values, and also you can feel free to kind of like revise the unit as you need. And also we have environmental conditions, and this is in the beginning, the initial value for temperature and also for pressure. And the same, you can change unit here. And also we have this reaction rates and reaction rate constant section. And for now it's empty, but I'm gonna show you like how to work for the tropospheric case. And we also have this involving section. So here, that means how things are changing when you're running this simulation. So we have time is changing, and also your temperature and the pressure could change. And also here, your catalysis can also change. So this is a section about like everything can change over the simulation. Okay, so I may kind of like accidentally added a few things just to show you over there. So just maybe we can start from a clean version here. So we choose the clean version, and then we check the species, we check the reactions, that's all we want. And also we check the conditions to make sure everything is what we want in the evolving conditions, and then we can run the model. So it's pretty quick because we have a relatively simple chemical scheme. And after you run, the fun part is you can make the plot, and you can plot the results directly through the MusicBox Interactive. And the same, you can change the unit here as you need. For example, if I change the ppbv, and then I'm just trying to like use this, a few examples to plot. So you can see there are different magnitude. Yeah, but you definitely can put a few species together. And for something which are like constant, and then that's they're not changing that much. And here you can see this like plus symbol. That means this is the changes based on the initial conditions. Mm-hmm. Okay, so after this, you can also download the configuration file and also download results. So once you're really happy with your simulation, you can download these and then to save them for future use. So just click these, and then I will just show like the things I already downloaded before. So one is the zip file, that's the configuration file, and also one is the output. So for the configuration file, if I unzip it, you can see there are like a few things inside. For my config.json file, you can see here are like the initial conditions we defined, and also some of the involving conditions. Yeah, so you can feel free to modify for your future simulation. And here you can also see something like pressure, temperature. These are involving conditions, and then you can see how they evolve across the simulation. And also you have this camp data section, and here I can show you this is a config file, like the tolerance, species, reactions. Also, we can see here, these are the reactions. So just follow the specific format, and then you can just feel free to add the species or add, the reactions yourself. Then just you can kind of build new reactions to use for future simulation. And that's the same for species, and just follow this format, and then you can add your own species. And the tolerance, again, that's related to the chemical solver. Okay, so let's also take a look at the model output. So for the model output, you can see here we have the time column and the temperature, pressure, and also the air density, and also here we have the concentration of different species. So you can definitely see how things are changing, and then you can use this downloaded data to make plots offline. So it's pretty fun and also really useful. Okay, so here you also notice for this downloaded, the output, you can also see like these are the reactions. So you can also see how reaction rates kind of changing. And going back to here, you can definitely also see something here, like the reactions, and then you can see how the rates gonna change. I wanna show you, yeah, so actually here. So if you plot and this as chemical species, you can also kind of make the plot for the reaction rates. And that's the same as you download it from this web page. And that's the same for environmental conditions. You have density, pressure, temperature. So everything stays the same for this reaction. Okay, so now let's also take another look at another example. So let's try to run this one. This is a full gas chemistry one. So it definitely has more species, a lot of VOC species, biogenic and also anthropogenic species are out here. And for reactions, and definitely we have more reactions. That's also mean that this simulation gonna take longer, and you need to kind of define and also select your simulation time wisely. If you choose like a really long time, like simulation time, it's gonna also take pretty long. So here, so after take a look at the chemical reactions and the species, you can also double check the conditions. So for this one, this is again still the box setup. We have this chemical timestamp as 1 minute and output timestamp also 1 minute. When we only do 3 hours simulation this time. And here for the initial conditions, you can see here we have the initial concentration for different species, and then we basically define like a lot of species here. And also we have these environmental conditions that's basically for the surface condition. And here you also have these reaction rates and reaction constants situation. So besides, so notice here, besides this initial like rate for the photolysis, you can also define the emissions here. So you can just definitely feel free to play with MusicBox and then to make it satisfy your need. Okay. And also we can take a look at evolving conditions. So in this case, we don't have any things evolving. So just the initial condition here, that's the thing we're gonna put into this model. Okay, so when everything is ready, we can run the model again. So now it's take a little bit longer because there we definitely have more chemical species and also more the reactions inside this mechanism. Okay, so we can just wait a little bit, and now it's ready, and we can just feel free to make the plots. And just for example, we can choose just something. Let's see whether we have something fun here. Maybe a radical, so you can see how things are changing here, and also you can see different nitrogen species, and like we also have the unknown species. Yeah, just feel free to play with these. And the same for reaction rates. And if you kind of like click open like different reactions, and then you can definitely choose the reactions you are interested in and to see how these reaction rates change across time. And again, as the same for the environmental conditions. And yeah, as I mentioned, there's no evolving conditions, so these are constant. Okay, so you can also download these files and then kind of like double check the results or plot the results as you need. Okay, so we go back to the beginning. As I mentioned, we also have a few two more tabs. One is start from scratch. So you can see here, this is only one species over there, pretty lonely. You can add a species, and as you need, you can also add reactions. But it's pretty harsh. Normally, I would just start with an example to make it simple. Okay, so if you want to start with the example, so load configuration file tab, that's your friend. Okay, so I'm gonna load what we saved earlier. Okay, so I'm gonna load from my download file. This is the one I downloaded earlier. This is a config zip file. I open it and then upload it. So you see here is just identify the same Chapman mechanism scheme. So you can see here the same chemical species and reactions, and also the same conditions. And you can feel free to run it, and then the results will also be the same. And so another resources I want to mention is last summer we also developed like a MusicBox curriculum. So I'm going to show you here. This is a MusicBox curriculum exercise. I'm going to share with everybody the link later. And you can see here, these are already like a few examples built inside. So if you click the stratospheric examples, we have the simple Chapman, we also have the full Chapman. And if you click open, so these are the conditions, the changing conditions. Like this one is at 20 kilometer, 30 kilometer. So you can download this zip file directly and upload it to your MusicBox directive and then play with it. So I downloaded one example from each. So let's try it. Okay, so that's still we use the load configuration file section. So let's choose the example. So I want to start with the simplified Chapman example, which is at 20 kilometers first. So I open it and I upload it. So you can see here we have less species than the default Chapman cycle example. And let's see the reactions. So we have the reactions here. And also the conditions. So we still run 5 days and a few initial conditions. Yeah, the temperature, pressure, and also we have these a few involving conditions, the same as before, like for the default Chapman. And then we can run the model. And let's see the plot. So we can see how things are changing and for different species. So because we did define like a few things, like the factors are changing in the zip file, so that's why like you can see this kind of shape. So when you are trying to upload like a configuration file, I mean, before the upload, you can feel free to modify this the content in the zip file and then make a new simulation. And here you can also see the rate, yeah, for different species, and so again how these things changing kind of depend on your setup. Okay, so similarly, I'm gonna try to show you the last example. This is the full mechanism one, the Chapman mechanism. And let's open it, upload, and you can see definitely we have more species, these catalytic species are trying to damage the ozone layer. So a lot of things are here. And also we have definitely more reactions and then like how different kind of oxidants can influence the ozone formation. And that's the same for conditions, like also the initial concentrations. So you can see this is a long list now. And here you also have this involving condition for different things. And as mentioned, like the way you define how these things are evolving can totally change your results. And then now let's try to run the model. So it will take a little bit longer because we definitely have a lot more species than our previous simulation. So we can be patient and yeah, should not take too long. And while we are waiting, and you can also see actually here, that's also the terminal kind of like run the simulation and show you like how far you are. And now it's ready. You can plot the results as we did before. And I just choose like a few species like randomly. So you can see how this concentration changes for different species, like for example, formaldehyde, and also like a few other like radicals. So yeah, so just feel free to play with these. And I think for now, that's all the demonstration, and just feel free to start with the practice.